Hello, I am Fadi Abu Shakra and I'm the product lead for ICP-MS.
Hello, I'm Hamid Badi, Chief Technology Scientist and the Director of Research and Development for Mass Spectrometry at PerkinElmer. Together with Fadi, we are going to walk you through our recent innovations on our Nexion 5000. But before we go there, let's start with some introduction.
Since its commercialization in 1983, inductively coupled plasma mass spectrometry, or ICP-MS, has become the fastest growing trace element technique available. The technique can cover the majority of the elements in the periodic table, and with detection limits often in subparts per trillion level. ICP-MS can also handle a variety of sample matrices, typically in applications with environmental, biological, as well as industrial, such as semiconductor and geochemical origin. PerkinElmer pioneered in the field of elemental analysis by introducing the first commercially available ICP-MS, the ELAN 250. The system had overcome a number of technical challenges to date, most importantly at interface between the plasma source and the mass spectrometer.
But as the market need evolved, PerkinElmer rose to the challenge with innovative technologies that met those customer needs.
But customers continue to need lower detection capabilities to measure ultra-trace impurities, for example, in fine chemicals used in semiconductor industry. So we took the challenge from our customers to improve sensitivity, eliminate interferences much more efficiently, and deliver a robust system with low maintenance. And the result was Nexion 5000, packed with multitude of innovations in plasma generation, ion transmission efficiency, low matrix effects, and unparalleled selectivity of a multi-quad geometry. The new generation of ICP-MS interface in Nexion 5000 utilized a patent-pending OmniRing to improve ion transmission through the interface with minimum losses and increase the sensitivity of the system by at least 5 times.
We also designed the first multi-quadrupole mass spectrometers. Now, some of you have heard of triple quads, but what is multi-quad and why is a multi-quadrupole better than a triple quad? To understand the difference between a triple quad and a multi-quad, let us have a look at them. In a triple quad, we have a high-order multiple cell, such as a hexapole or an octopole, sandwiched between two quads. The purpose is to control what enters the cell. The ions entering the first quadrupole are filtered based on their mass-to-charge ratio, and only one mass is allowed through. In this example, we're looking at mass 52, where we have the analyte of interest, chromium plus, and the interference, argon-carbon plus. As these ions enter the multipole, they collide and react with the gas in there. In this case, chromium does not react with ammonia, but argon-carbon does. That's great, we got rid of the interference. But look at what happened to the ammonium ion, which is the byproduct of that reaction. It reacted to form a cluster ion at mass 52. So we eliminated one interference only to create another. So how is a multi-quad different from a triple quad? Well, on a multi-quad, Q2 is a quadrupole with mass filtering capabilities. Let us go back to our example. The ions enter Q1 and are filtered so that only ions at mass 52 can go through. That is chromium and argon-carbon ions. These ions enter the cell, or Q2. Argon-carbon reacts with ammonia and loses its charge. So we got rid of it. But now the ammonium ion is immediately rejected before it can react with anything else. So only chromium ions leave the cell and only chromium is observed. In the multi-quad, we do not only control what enters the cell, we control what happens in the cell, leading to total confidence in the results.
The RF generator of the system is the latest technology in plasma generation that uses the best-in-class solid-state technology in a patented circuitry. The system operates at 34 MHz, to ensure both plasma robustness and maximum RF coupling efficiency by utilizing the patented Lumicoil design. The combination of triple cone interface and the quadruple ion deflector ensures that downstream ion optics are protected from heavy matrices and the deposition of impurities that would otherwise cause instrument drift and loss of sensitivity. This is how we guarantee no required maintenance inside the mass spectrometer to our customers.
For unmatched detection power, for phenomenal stability, PerkinElmer Nexion 5000, simply the best. Thank you.